Okay, so in pure Aloha, we say that the vulnerable time is nothing but 2 into 2 TRF, means it was a very large. So means what? When one station transmit the data, it has to reach and it has to come back, means there was a delay or there was a waiting time, it was too large in the slot in a pure Aloha case. So we wanted to reduce that pure Aloha, that is a waiting time for the each station. So we have come up with one more type of Aloha protocol or one more version of the Aloha protocol, that we are going to call it as a slotted Aloha protocol. In slotted Aloha protocol, what we have done is, so we have done the data transmission in terms of frames. So means what? Whenever a station wants to transmit the data, it has to transmit only the starting time of each duration of the time. Okay, so this duration we have called it as a time slots, that is the limit TFR. Okay, so means what? Whenever a frame wants to transmit the frame, it has to start the moment what TRF will be initiated. So when TRF is initiated, the moment it starts, the all the stations should transmit the data if they have, and if they don't have any data, they should wait for the data to be appearing. And if they get the data already, if TRF has been started, means then they has to wait for the next TRF to be initiated. When the next TRF is initiated, then all the frames can able to transmit the data. So means what they have done in this slotted Aloha protocol is, so the moment when you get to receive the data, it is not possible for you to transmit. You have to wait for the TRF second. So means what? The moment when the TRF second started, so then only you can able to transmit the packet. So this was the modifications which has been done when compared to the pure Aloha. So you can see here in the frames in the slotted Aloha, the given time. So the given time, it has been divided into 6 slots. So you can see here each slot is of duration of TFR. So means TFR is the duration with which the station has to transmit the data. So you can see here in the slot 1, the only one station had the data. So therefore it has transmitted the data. So no other slots have the data. So therefore the station 1 data can be reached successfully. But whereas in the case of slot 2, you can see here the station 2 and the station 3 both are transmitting the data. So therefore there is a possibility of collision will happens in the station 2 and station 3 in the slot 2. Whereas in the case of slot 3, so there also the station 1 is transmitting the data and the station 4 is also transmitting the data. Therefore there is a possibility of collision may happens in the slot 3. Whereas in the slot 4, slot 5 and slot 6, you can see here in the slot 4 only station 2 is transmitting, in the slot 5 only station 4 is transmitting, and in the slot 6 only station 3 is transmitting. So means what? By dividing the given time into frame slot, it is possible for us to avoid the collision. So now you can see here the duration of collision, it has been reduced when you compare to the slotted Aloha protocol. So the vulnerability time in the slot in the pure Aloha protocol, it was 2 into TFR, whereas in the case of slotted Aloha protocol, it will be TFR only. So means what? The waiting period of data transmission or the collision period of data transmission between the, when you compare to your pure Aloha with the slotted Aloha, it has been reduced by half of the percentage. Okay, so that is what the difference we have done in the slotted Aloha protocol. Okay, so that is basic difference between your pure Aloha protocol and your slotted Aloha protocol is that in slotted Aloha protocol, the moment you get the data, it is not possible for you to transmit over the channel. You need to transmit the data when the TRF is initiated. So means when the TRF timer has been started, that in that moment only you need to stop. If you get the data when already TRF has been initiated, means then you need to wait for the next TRF has to initiate. So then only it is possible for you to transmit the data. So through the use of division of time into number of frames or number of slots, we can able to minimize the number of collisions in the which was there in the pure Aloha protocol. So that is why the name is called as a slotted Aloha protocol. Shall we go for the next one?
Yes, sir.
Therefore, you can see here the vulnerability time. So the moment of the time needed for to you to detect the collision, or the time needed for you to transmit the time. So you can see here the vulnerability time in the case of slotted Aloha protocol, it is nothing but only 1 TFR. So why? Because the when you transmit the data, it is the possibility of collision may happens only in this time slot. Okay, so whereas it does not affect to the next time slot. So therefore, the vulnerability time, that means the sensitivity with which the output will not change, which will change the output. So that we are going to call it as a vulnerability time. So in the case of vulnerability time for the slotted Aloha protocol, so we are going to call it as it is only 1 TFR. So therefore, if you consider this vulnerability time and if you find the throughput of this slotted Aloha protocol, so we can say that the throughput of the slotted Aloha protocol, it has been doubled when you compare with the pure Aloha protocol. In pure Aloha protocol, it was 184, but whereas in the case of slotted Aloha protocol, it will be 0.368. That will be getting when G is equal to 1. Okay, so therefore you can see here the throughput of successful data transmission in the slotted Aloha protocol, it is nothing but S is equal to G into e power minus G you will be getting. So when you substitute G is equal to 1, so you will be getting a maximum throughput, that is nothing but S is you will be getting 36.8 percentage. Okay, so in the case of slotted Aloha protocol, your S will be G into e power minus G, and the maximum throughput what you will be getting is S is nothing but 0.368. That is nothing but when G is equal to 1, so you'll be getting 36.8 percentage of the total frames which you are going to transmit in a slotted Aloha protocol will be free from error. Okay, so that is what we can do the conclusion in case of a slotted Aloha protocol. So I request all of shall we go for the next one?
Yes, sir.
Yes, sir.
Okay. And try to do the problem for this the same thing, but we have changed only in case of pure Aloha you just change to slotted Aloha. Try to find out the values for this. You can see here, if you try to do it and tell me the answer for this problem. Please do it everyone and tell me the answer. A very important method what we are going to call, or when we used a wireless LAN, or when we are going to use a wireless LAN technology implementation, very important mechanism what we are going to do in order to transmit the channel over the or transmit the data over the channel is carrier sense multiple access method. This is a very important topic for you people. If you understood this carrier sense multiple access topic very effectively, means then the remaining topics, or if you are a very good means CCN student, means then you should know this carrier sense multiple access concept as good as possible. Okay, so what do you mean by carrier sense multiple access is that, so you can see here in the previous two methods, so whatever we have studied, the slotted Aloha protocol and pure Aloha protocol, whatever we have studied, see what we did is whenever you have a data, we transmit it. In pure Aloha protocol, what we did is I get a data. The moment I get the data, I am going to transmit over the channel. In slotted Aloha protocol, what we have done is, okay, I got the data. Whether TRF has been initiated, yes, TRF has been initiated means then the moment when TRF is initiated, I will be transmitting the data. If you got the data once the TRF has been initiated, means what we are doing is we were waiting for the next TRF is to be initiated. So when the next TRF is initiated, we were transmitting the data. So means what? There was no question of accessing the channel, means there was no question about whether the channel is free or not. So we were not bothering. So what we were bothering, whether I can able to transmit the data or not. Okay, at this moment of time, it is not possible for me to transmit because of the TRF has been already initiated. Okay, I will wait for the next TRF. Means what? Other station what they are doing, whether they have transmitted successfully or not, whether they are still transmitting, whether I should keep it quiet. So all these things we were not bothered about in the previous methods. But whereas in the case of CSMA, that is carrier sense multiple access, what we do is before we transmit the data over the channel, first we used to sense the channel. First we used to see the channel, what actually it is doing in the channel. whether already someone has initiated the channel, someone has initiated the data transmission. If someone has initiated the data transmission, what I should do? So we will be having some rules and protocols for that. And if I have a data, and if someone is already initiated, means okay, I should wait for it some certain amount of time. Okay, after waiting for certain amount of time, what I should do next when I want to transmit the data? So what I should do, again I should sense the channel. Okay, if someone is already accessing the channel, means then what I should do, again I should wait for the some more amount of time. So all these mechanisms we were not able to see it in the earlier cases. But in this carrier sense multiple access, before I transmit the data, I should sense the channel whether it is free or not. So what we are going to call it as, because of this mechanism, sense before transmit, or it is also called as a listen before talk. Okay, so therefore when you want to transmit the data, or when you want to transmit the data without any loss of packet, then you should go for a carrier sense multiple access method. So in this carrier sense multiple access method, what we do is we will sense the channel whether the channel is free or not. If the channel is free, means then I will transmit the data. So by this we are able to reduce the collision. So we cannot avoid the collision, but we can able to minimize the number of collisions what we were happening in the previous cases. Okay, so in order to understand this how this CSMA is working, so you can see here in the figure 12.7, so we have four stations are there. So the station A, station B, station C, and station D. So you can see here B starts at a time T1 and C starting at a time T2. Okay, and we have given some means when T1, when station A is transmitting, it wants to access the channel. So it see whether the means whether the someone has already initiated or not. So if someone is not initiated, means then the remaining stations will try to access the channel, and they will try to transmit the data. So because of this mechanism, so we can see here when B starts at a time T1, when B starts at a time T1, so it has covered some area, means it has transmitted some data. So where it has been transmitted the data, so it is propagating the data at a time T1. So the moment B starts transmitting the data, so we say that B has occupied some area over the geographical location. So that area we were represented in a shaded fashion. So you can see here the moment B start transmitting, so it has occupied the data. So means what, it has transmitted the data to the station A also, station B also, and the station C also. So now you can see here, so T1 is the B when it is started. So T2 also transmit at some instant of time. So let's say, because see here when B1 is transmitting, so that whatever the signal it has been transmitted by B1, it has reached to station A quickly, whereas it is does not reach to station C quickly. Why? Because the distance between station B to station A, it is minimum when you compare to the distance between B to C. So therefore when at time T2, since when it senses the channel there is no one is transmitting, because the B signal has not been received across the C. So therefore what C thinks that, so station is free, so it will start transmit the packet. So when it start transmitting the packet at a time T2, so you can see here in the right corner D. So D will successfully receive the C's packet, whereas it cannot receive the packet which has been transmitted by B. Why? Because there has been already a collision has happened. So in this collision is happened, so therefore the packet which has been transmitted by B will not be reached to D because of the collision. And also the packet which has been transmitted by B can be reached to station A, whereas the packet which has been transmitted by C cannot be reached to A. Why? Because you can see here at some instant of time, both, that is the C's packet and B's packet, they are overlapping to each other. So because of that overlapping, the station A cannot access, or station A cannot access the frames which has been transmitted by the C station. Similarly, the same applicable to station D. So the station D can easily receive the packet from station C, whereas it does not receive the packet from station B. Why? Because in the same time station C also transmitting and the station B also transmitting. So therefore there is a possibility of collision will happen at the case of D terminal. Okay, so when it was only B, there was no collision, but when a C is transmitted, there is a collision. Why? Because there is a propagation delay is there. So because of this propagation delay, we can expect some amount of collision will take place in the carrier sense multiple access mechanism. So for this carrier sense multiple access mechanism, we should find out what is the vulnerable time. So means what? At what time the station should transmit the data. So the station should transmit the data when it does not get any frame within the vulnerable time or within the propagation delay. So because of the propagation delay only the C station has transmitted the data, because it was not reaching the data at the moment when the B has started at time T1. So therefore at time T2 the station C also started transmitting. So means what? There is a propagation delay is existing when a station transmit a frame. So because of this propagation delay, the other station is not able to see whether the station is free or not. So therefore, they should wait for some amount of time. So what is that amount of time they should wait? They should wait for an vulnerable time. So in the case of CSMA method, the vulnerable time, what we are going to call it as a propagation time, and this has been represented by the notation called as TP. So when a station needs to transmit any frame to any other frame, so it has to wait for a duration of time called as a TP. So when it has waited for a time duration of TP, if it does not receive any frame means, then a station can able to transmit the time. So this is how the carrier sense mechanism will take place in a CSMA method. So in order to understand this vulnerable time in CSMA mechanism, so you can see here they have given a figure 12.8. So in the figure 12.8, you can see here the moment when A start transmit, so it takes some amount of time to reach to station B. Okay, so this station B, what is sense? Okay, it senses that okay, the station A is transmitting, so I should wait for some amount of time, and this frame will reach to station T again at some amount of time. So means what? C senses again, okay, so it has to wait for some amount of time. Okay, when the frame which has been transmitted by A, it reaches to the destination D, it has waited for some amount of time. So what is the amount it has been waited? It has waited for an amount called as propagation delay, which has been exerted by station A when it wants to transmit a packet from A station to station B. So therefore, all the stations we have covered, so the maximum amount of waiting time for the station D is nothing but the propagation delay which has been exerted by the frame from station A. So therefore, we can say that the vulnerability time for this CSMA was the propagation delay. Okay, so therefore in CSMA mechanism, if the station, any station wants to transmit the data means, then they should wait for propagation time delay amount. So after propagation delay amount, if the station is again it is free means, then I can able to transmit the data. So this is how the station will transmit, that is the sense the channel, and they will wait for it. If the channel is free, they will wait for propagation amount of time. After waiting for the propagation amount of time, they will transmit the data to the corresponding station. Okay, so this is how the working mechanism will take place in the CSMA